Welcome to M2. In this video we're looking at centre of mass of a set of particles arranged in a plane. Now in the last video we looked at this on a straight line and I focused just on the x-axis or the x direction, horizontal lines. Now we can apply the same logic to vertical lines. Exactly the same method as what we used in the previous one, but with vertical lines. So if I think back to the previous one, while I didn't actually mention it in the video, if you do look at the course notes, what you'll see is, or from your own logic, but what you'll see is that the sum of our masses multiplied by those distances were the same as the mean distance multiplied the sum of the masses. And I'll just put the kind of terminology in here in terms of our values. So going from one mass up to n number of masses, so it's just essentially the mass times the distance all added together is then the same as the mean distance multiplied by the mass. That is essentially what we got out of it in the last video, although we didn't look at it algebraically. And equally, we can apply the same logic, as I said, to our vertical ones in terms of y. So sum of our masses multiplied by our y distances would be equal to the mean of that y distance multiplied by the sum of the masses. And again, I'll just fill in the terminology properly on these, but that's essentially what I'm doing. Now I can apply both of these, the x and the y, to then look within a 2D plane. So if I want to find, where my center of mass is, it's essentially to do with that average y distance, the average x distance, finding that point. Now, I would say it's much easier to explain with an example, so that's what I'm going to do now. So here we have a very short, small x and y graph with a bit of grid on here so you can see it clearly, and we've got three masses, different positions. And just like I thought of in the previous one, when we had our first line, if I then think of that then as a single mass, a center of mass, okay, it's going to be on, of course, the same xy grid. Somewhere in here will be this center of mass with a mean x and a mean y value. Now, previously we would have just taken moments about the origin, and that is essentially what we are doing, but we need to look at them separately. So in the first instance, I am essentially going to take moments about the origin, but really about the y-axis, because I just want to focus on that horizontal one. So that's where my first set of moments are going to be. And then after that, I'll take it about the x-axis. But before we jump into that, we need to look at the masses, don't we? So a total mass for the three masses is going to be 2 kilogram weight, a 3 kilogram weight, and a 5 kilogram weight or mass. So that's 2g, 3g, and 5g. And this is, of course, going to be equal to my mg. And in these cases, g is always going to cancel out, isn't it? So I know that my total mass is going to be equal to 10. Now, back to taking moments about the y-axis. So here we're just looking at this distance, this perpendicular distance to the y-axis. So if I think of my 2 kilogram, that's going to be 2g multiplied by 1. My 3 kilogram is 3g multiplied by 3. And my 5 kilogram is 5g multiplied by 4. They, of course, are equal to my mg multiplied by x bar. As before, and as we kind of starting to get used to here, our g's are in everything, therefore they can cancel out. That is 2 plus 9 plus 20 equals m times x bar, but m we know is 10, so 10x bar. So we got 31 equals 10x bar, x bar equals 3.1. Now I need to take moments about the x-axis. So take moments about x-axis. And again, here now we're looking at this distance. So the 2 kilogram weight has a distance of 2 here. 3 kilogram weight is 1. And that 5 kilogram weight has a distance of 3. And that, of course, is equal to m times y bar. But m is 10, so 10 y bar. Oh, I should really put the g in here, shouldn't I? Because we haven't cancelled them yet. It's taken too many steps ahead. So cancelling my g's. I know some of you are probably thinking, well, why even bother putting the g in there? But you should, because you know you're not always going to deal with mass. There might be within the question a value for force in terms of newtons as well. So it is important to always keep getting in that habit of putting it in it, even though you know in these kind of early parts it is going to cancel. So working out my values quite quickly here, we get 22 equals 10 y bar equals 2.2. Therefore, the centre of mass is at 3.1, 2.2. So all we're really doing is combining what we did last video in terms of horizontal with the equivalent vertical and putting them together. There's nothing, you know, too difficult about this. Okay, but it is an important skill as we start to move forward into this particular unit. Now, with this example, it's quite straightforward, but always kind of start with a sketch. So we got A, B, C, D. And of course, before I did the sketch, I just checked which length was the shorter one. So you can see this is 15 and this one is 30. Now, at each of these points, and I'll do this in red so it stands out nicely. So at A, we have a mass of 3g, or 3 kilograms. At B, there is 5 kilograms. At C, there's 7 kilograms. And at D, there is just the 1 kilogram. Now we need to find the distance of the centre of mass of the loaded plate from AD and then AB. What this is actually asking us to do is essentially find the distance of the coordinate of it from A, because we're going from AB and AD. So we're essentially going from this point. And that's something to bear in mind. You know, you can, in this case, you know, you would go from this point anyway because that's what you're trying to find. But in other questions, you know, you might want to pick a specific point because it might get rid of something or a value that's quite awkward. Because, for example, at this point, these distances, when I look horizontally, are going to be 0. And then at this point, this one here is going to end up being 0, these two. Okay, you'll see when we start to do it, but it sometimes pays to pick a specific point. So what I'm really doing here is I'm essentially taking moments about A, thinking of the horizontal distances, and then the vertical distances. And I'm going to look at them as vectors. So we kind of come in from this point. So we think of at A, this has a mass of 3 and a distance of 0 and 0 in terms of its vector. If I look at B here, it has a mass of 5. It has a horizontal distance of 15, but it has a vertical distance of 0 because it's on the base. Yeah. When I look at C, we've got a mass of 7. It has a horizontal distance of 15 and a vertical distance of 30. And then when I look at the 1 kilogram at D, it has 0 horizontal distance and 30 in terms of its vertical distance. Now that's going to be equal to my total mass, which is 3 plus 5 plus 7 plus 1, multiplied by that average x and the average y, or x bar and y bar. So what we've done here is essentially make a little bit of a shortcut. So instead of having to take our moment separately and doing like 3 times the x distance, 5 times the x distance, and so on for just the x's, and then use almost the same values, certainly for using the same values for mass, and then do the y values, in this form we can write it out in one go and work everything out quicker. And that, as I've said in numerous other videos, that's what it's all about, isn't it? It's about the speed. So first one, 3 times 0, 3 times 0 is just going to be 0, so I can basically get rid of that one. So let's get rid of that one. Now my next one, we've got 5 times 15, which is 75, and 5 times 0 is 0. Next I got 7 times 15, which is 105, and then 7 times 30, well that's obviously got to be double it, doesn't it? So 210. And then finally 1 times 0 and 1 times 30. Now on this outside bit here, total this up, so 7 and 3 is 10, so we got 16 x bar y bar. Next step is to simplify these. Now I'm taking extra steps, but obviously you could have done it straight from that first line. So adding across the top my x values, I get 75 plus 105 is 180, plus 0 is just 180. Adding along the bottom is 240. And that of course is equal to 16 x bar y bar. All that's left to do now is divide by 16. So 180 divided by 16 is 45 over 4. And 240 divided by 16 is 15. Now that you can see that it's a single vector and a single vector, that means the top must be equal, the bottom must be equal. So I can quite comfortably say that x is this 45 over 4, or 11.25, and my y distance is 15. So if now I'm talking about how far the centre of mass is, then we can say that it is 11.25 centimeters from AD and 15 centimeters from AB. And finally, before I do finish, I check to see if my answer makes sense. So first 11.25 across, 15 up. So we're looking around here. Well, it's within the plate. So we got that to start us off. It's closer to this side, which makes sense. We got two heavier weights here, or masses, than this side. So to be closer this side. And then if I look at them, 1 and 7 is 8. 3 and 5 is also 8. So to get a value across the middle, in terms of the height, totally makes sense. So somewhere around here, my answers make sense. And you should always think of that kind of logically. Do your answers make sense? Now, hopefully I've given you just enough to get started on a few questions in terms of planes. So just pop a few up in a moment. Don't forget to pause them. And as always, I'll go through the answers at the end of the video.